10.3, we move to operations on Taylor series. So in this section, we're going to learn how to add, multiply, perform substitution, integrate, and differentiate Taylor series. Yes, these are infinitely long series. They have infinitely many terms, and we're going to be adding them, multiplying with them, substituting. We'll see what that looks like. We're going to integrate an infinite series and differentiate an infinite series. Sounds a lot more intimidating than maybe the reality. One reason that's the case is this note here on the side. We're going to be performing those operations on what we call the basic Taylor series. So in 10.1, we created Taylor polynomials from scratch, right, using derivatives and plugging numbers in. At this point, we've kind of developed that, that thinking that, we can come up with Taylor series or Taylor polynomials if we need to. And so, at this point, we're going to kind of leave that behind, and we're going to use what's called the fundamental or the basic Taylor series. There's a list of them in your textbook at the very beginning of 10.3. So I'm going to be referencing that. Also, I posted an image just above this video there in Canvas. So I just took a picture from the textbook. So it was right there and convenient for you. So I'll just show you what's in the book itself. So there are 6 basic Taylor series. So here I am in 10.3. Okay, and right there, here they are, page 597 if you have the textbook. These are them. So let me, maybe I'll zoom in just a bit and we can chat about them just for a moment. So sorry if it's still a little small, but I've got 1 over 1 minus x. There's the Taylor series, and it's just in the expanded form. It's not in the sigma notation, which is nice. And they give us the interval of convergence of each of these. So we've got 1 over 1 minus x, 1 over 1 plus x, the natural log of 1 minus x, the natural log of 1 plus x. Now this is really small. It's probably too blurry, but e to the x and e to the negative x. So we've got all of their Taylor series. They give us the first 3 terms, and then they give us the nth term of each one. And like I said a moment ago, they give us the intervals of convergence. You notice the first 4, the interval is always -1 to 1. For the e, it's everything, negative infinity to infinity for both of those e's. Okay, so we're going to be coming back to this for every problem because we're going to be doing operations on these things, so we're going to have to know what their Taylor series are. And okay, get that out of the way. Let's see. I think we're just going to dive right in and do some addition. Yeah, okay. Here we go. We're going to start with addition. Oh, I got to zoom back out. Okay. Get all this lined up. Use addition to find the Taylor series centered at 0, then state the interval of convergence. And we're going to be looking at this. F of x is 1 over 1 minus x plus e to the x. So what will it look like to get a Taylor series here for f of x? Well, maybe not surprising. We're going to write the Taylor series for this part plus the Taylor series for this part. Then what do we do after that is another story, but let's just start there. So I'm going to use my basic Taylor series, that table, write this one, put a big set of parentheses around it, plus big set of parentheses, and write this one. So here's how that looks. This is 1 over 1 minus x, 1 plus x squared, plus ... plus x to the n. Really interesting, the Taylor series there, it's just adding powers of x to the 0, x to the first, x squared, right? Okay, so all that plus, and here's e to the x, 1 plus x plus 1 over 2 factorial x squared plus dot dot dot. There's the nth term, 1 over n factorial x to the n. In general, it's got the factorial in there. Okay. So what does it mean to add these? Well, really we're just going to simplify. Well, what does it mean to simplify? And it really just comes down to combine like terms. Just like you were adding any other polynomials, you would combine the constants, right? You would combine x to the first, you would combine the x squareds, that sort of thing. That's really what we're going to do. So I see 1 plus 1. All right, combine like terms. That's the key. So here, I've got 1 plus 1. Okay, well, that's 2. So it happens it's x plus x. Well, that's 2x. X squared plus 1 over 2 factorial x squared. Well, 2 factorial is 2. So this is really like 1 plus 1 half. So I've got 3 over 2 x squared. Okay. Plus, and then where I see the dot dot dot, I'm just going to repeat that. There should be a plus sign here that I forgot. Plus, okay, what happens with the nth term? So the nth term, we might not be able to simplify it quite as nicely as some of the other ones. That's okay. Here's what we're going to do. 1x to the n plus 1 over n factorial x to the n. We're just going to say, set of parentheses, 1 plus 1 over n factorial x to the n. Plus, and then dot dot dot. That is the Taylor series for the addition of 1 over 1 minus x and e to the x. Simplified. We got it. Just like that. Okay. They also asked for the interval of convergence. So again, I'm going to have to pick this up on the another page. We're going to have to go back to that basic table list. What is the interval of convergence of our new function? The interval of f of x, the interval of convergence. Well, we need to look back at its different parts. So in the table, the interval for 1 over 1 minus x was between -1 and 1. The interval for e to the x was -infinity to infinity. So here's the thing. We need to pick one of these to be the interval for f of x. And when I say pick, we don't get to choose. One of them is right, one of them is wrong. But it turns out it's one of those. Which one would be the interval of convergence for f of x when we add them? And the answer is the more restrictive one. Always pick the more restrictive interval. So in this case, that's -1 to 1. You might write it this way, or you might write it in interval notation like that, -1 to 1. Why is it that we pick the more restrictive? Well, for e to the x, we're allowed to pick anything, and that series will converge. But 1 over 1 minus x, we can only pick values between -1 and 1. So the thinking is the values between -1 and 1 work for both of them. And so we need the interval that works for both of them as the interval for f of x when we add the two together. Which one works for both? Well, the smaller one, the more restrictive, works for both. If we stray outside of -1 to 1, that would work for e to the x, but it wouldn't work for this anymore. And we can't, that's just not gonna, that's gonna diverge in the combination of the two. Okay, so pick the more restrictive. What's nice is our basics, most of them are this. So if they agree, if they're the same interval, then you just pick that. But in the case where you've got two different ones, then you always pick the smaller. Okay, that's adding. Let's multiply. use multiplication to find the Taylor series centered at 0 for this function here. And then again, we'll find the interval of convergence. Okay, try and fit that all on the screen. Here the function is f of x equals 3x to the fourth multiplied with the natural log of 1 plus x. So what is this all about? Notice we are not multiplying two basic Taylor series. Only this one is a basic Taylor series. That's just another term that gets multiplied with it. So here's what we'll do. We will take the Taylor series expansion for natural log 1 plus x, and we'll just write 3x to the fourth out in front of it. Slide this down a little bit so you can, it all gets in the picture there. Okay. So here we go. This part just, is going to get copied down as a multiplying. Here's our expansion for natural log 1 plus x. X minus 1/2 x squared plus 1/3 x to the third minus, we got the nth term. You notice they're going between positive, negative, positive, negative. Negative 1 raised to the n minus 1. We'll do that. In this case, over n, and then times x to the n, plus dot, dot, dot. Okay. Well, what's it going to mean to multiply? Well, simplify, right? So, if this was any other polynomial and I wanted to simplify, I would distribute what's out here. So we're just going to do that. We're going to distribute. Now, it's got infinitely many terms to multiply with, but we don't have to write them all. Distribute, okay, that's the key. And here it is right here. 3x to the fifth minus, let's call this 3 over 2 x to the sixth when it multiplies to that. To the next one, well, the 3's cancel and I get x to the seventh minus dot, 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 plus, okay, when it multiplies to the nth term, well, I'm just going to put the 3 up on top. 3 times negative 1 raised to the n minus 1 over n. And the x's, well, x to the fourth times x to the n, we still need to add to simplify. So that's x raised to the n plus 4 plus dot, dot, dot. And we got it. All right, we still need the interval of convergence. Well, there's not a whole lot to say here, so I think I've just shown you the answer. The interval for f of x, well, all we need to worry about is this interval. That doesn't come into play. So we just look at the interval of natural log 1 plus x, and since that's the only series we were working with, then we just take that. We don't have to think about a more restrictive since we only have the 1. So write it either way. The textbook likes it in this style, but interval notation is a good way to go as well. And there it is. -1 to 1. Okay, let's stop this first video here. We're going to look at substitution next.